In the earlier class, what we saw? Vectors, correct? Vectors and the operations, mathematical operations using vectors. And in this class, we will see there's one more important mathematical method which will be which will be used very much in physics. That is what? That's what you called as calculus. Okay. And okay, this method was basically developed by Leibniz and Newton, the mathematicians. Newton is the same, Sir Isaac Newton, who have the Newton's law and all. They were the two people, two giants who developed this entire technique of calculus. Okay. So, and it will come into two types of calculus, differential calculus and the integral calculus. We will see it, what it means slowly. Okay, so first we will see what is calculus, the technique. Let us first see what is the differential calculus. Okay, and then I will speak about the integral calculus. Suppose let us, and how it is connected to physics, that we will see that. Okay, let us take a fun story. So you are returning from school. Okay, so let us calculate what is the speed you walk down to home. Okay, do you walk in a constant speed? Okay, first you will be slow because you will have a lot of friends will be there. You all will be slowly chatting and walking. Then slowly one by one friend will get into different directions. Then slowly speed up. Then finally you will be alone. Then you start walking fast. When you reach near the home, then you will start walking fast, or maybe sometimes you may run. Either you may be feeling hungry or you may want to go to the restroom. Okay, so whatever it is. So whatever. So you are not going to, from your school to home, you are not traveling at a constant speed, right? You are constantly traveling at a different speed or different velocity if you have a vector. Fine. So now if I try to plot it, whatever I said, from your school to home you are reaching. If I plot it the distance wise, suppose let us say your school is how many meters from here? Say 100 meters, for example, 100 meters or 200 meters we'll keep. So I am going to plot your distance of your school in the y-axis. This is distance from your home. And here I am going to plot the time taken. Okay. So the distance is, I said 100 meters. So let me write it as 10, 20, 30, 40, 50, 60, enough. Okay, up to 70. We'll keep it up to 70. Okay, and the time taken, maybe you must have taken, let me try to see after 10 minutes what distance you have traveled. So let this be 10 minutes, 20 minutes, 30 minutes. 30 minutes will be too much for 100 meters. You must be crawling on the road, right? Okay. So let us not put it in, let us say it's as 10 seconds or 20 seconds. Okay, some minute. Okay, I won't put 10 minutes. 1 minute. That is better. Okay, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes and 6 minutes. Let us keep it like that. Okay. And so typically the way, the distance, how you are traveling, because you are slowly traveling, right? Because I can actually plot at every point what's the distance you are from. Okay, so at 0 you are going to start from the school. This is 0. So you slowly go. So if you are at a constant speed, what happens? This will be a straight line. Am I right? Okay, because then you say for every 1 minute, you must have, So you must have traveled same distance, correct? So what is that? If it's a straight line everywhere, so if for even this minute also, every 1 minute you must have traveled same distance, right? This distance is going to be same. So but you are not doing that. Okay, so you are having, how you are going to do, you are not walking like that. So how you are walking is, because initially you had a lot of friends and so you are very slowly you are walking, and what you do is, first you will be very slow and then you slowly pick up the speed, and when you reach the home you start running. Correct? So now if you see this plot, so let us see it for here. For 1 minute, you have traveled this much distance, correct? And let us see for the later on. So this is a smaller distance you have traveled. Now let us calculate from here. So in this 1 minute, You can see here only this distance. Let us call this as say some A. And here you have travelled up to B. So obviously B is larger than A. Am I right? So the reason is because you started running. Okay, so now the question I am asking is, so let us put up the question. So what is your speed you are walking during your say 3 to 4 minutes? During 3 to 4 minutes, what is your speed? I am asking you. How will you calculate? Tell me. So what you do, what am I telling is, so you are having here like this. So let me remove all these lines. Okay, so there won't be any, we'll make a neat curve, neat plot. Okay, so we are having this curve. This is your trajectory from school to home. I am asking, what is your speed during 3 to 4 minutes? So what you do, you make a line here, 3 to 4 minutes. So the time taken is 1 minute, and this is the distance. Okay, so this is the distance. So let us call this distance as d, and this as time is t. Okay, and the speed is what? Distance traveled by time. So then the velocity or speed, whatever you call velocity, will be distance displacement. If it is velocity, this will be displacement. You put an arrow. Okay, for time being, let us keep it speed only. Okay, we will not have a displacement. Speed. So speed also I am writing it as v. V is equal to d by t. Am I right? So what is this? This is the speed you have travelled during the time 3 to 4 minutes. So what this is, d by t is? Do you know what is d by t? From this plot, can you find out what d by t is? Okay, let me tell you. So this is the point, right? So I am going to say, so this is the point here and this is the point here, correct? Let me, don't have a scale. Okay, fine. So let me draw a straight line joining, we can draw a straight line joining these 2 points. Okay, so let me tell. So this is what, can you tell me what is this point? Suppose this is D, right? So if I write this one as Y, so this will be 3, Y. Very good, correct. So this will be what? 3, Y. And what about this point?
4,
this is distance. Distance is D. This is Y.
D
So
minus y.
D minus Y.
Oh,
This, what is this distance?
Oh, that distance.
What
Y
is,
plus D.
Y plus D. What happened?
And the whole distance.
Okay. So now tell me what's the slope? Slope of this line. Let me call this line as, okay, some line is L. Let us call it line. Let try to tell me what is the slope of this line. Y1 minus Y2
Will be x1 minus x2.
divided by x1 minus x2. That's what you studied in a maths class, right? So what is y1?
Y plus D.
Okay, y plus d minus
Y.
y.
Will be 4.
Okay, so let me call, I will not call this as t. Okay, so we will call, so this is the duration t we have taken, right? So I will call this point as, so instead of 3 and 4, let us call this point as x. Okay, and so this duration is how much? T. So this will be x and this will be x plus t. Am I right? So therefore 3 will become what? This will be x, correct? And this will be x plus t. Am I right? Right or wrong? Correct? These are the 2 points, right? So what are you going to do? We are given 2 points. We are going to find the slope. Slope is what? Y1 minus Y2 divided by x1 minus x2. Y1 is y plus d minus y divided by x1 minus x2. Tell me what is x1 minus x2?
X plus T minus
X plus t minus x. So y cancels, x cancels. What do you get?
D by T.
D by t. So what is d by t?
Speed.
This is the speed. So basically what you do is, this is a slope. So if I ask you what is your speed between the time t and or between the x and x plus t, what is the speed you have traveled? You take the 2 point, draw a straight line and get the slope, and that's what your speed is. Am I right? Clear? So now I'm asking. Okay, now I am not asking about x plus 3 and 4 I asked, right? Now I am asking, can you tell me what is the speed between 3 and 3.5 minutes? 3 minutes and 3 minutes 30 seconds. So you take a point in between, then join a line, correct? You keep doing that. And now I keep asking, so okay, now can you tell me what is your speed at 3 minutes, between 3 minutes and 3 minutes 10 seconds? Take a point and do. And now I am asking, what about 3 minutes and 3 minutes 1 second? Okay, and I keep on asking you, finally ask, can you tell me what is your speed at 3 minutes? You got it? So what we have done, if I ask you, keep on asking you that questions, what you basically do is, when I tell you 3 and 3.5 minutes, you take a point here and then draw a straight line, correct? And if I ask you further smaller time, then you take a point here, draw a straight line. If I keep on asking, at one point, if you ask, tell me just the speed at 3 minutes, what will you do? That will be the tangent. Exactly. So, right. So, because that's a tangent at that point. So, when I ask you what is your speed at 3 minutes, in our case here, we call it as x minutes. Say some x minutes. So, the moment if I ask you what is your speed at x minutes, let us call the x is here. Okay, the x minutes. So, then the speed is nothing but the tangent to this curve which passes through the point, single point x. Okay. See, any line which passes through, touches a single point to a curve, we call it as a tangent. That is a circle also. So, that's what. So, basically, now how you are going to arrive, find out the tangent. Okay, and this method is what you call as this method of, okay, here I took it as speed when you take it for any function. Okay, so what it says, so this is a distance. I can simply have the speed versus time. Then the acceleration, correct? So speed it can be any function, any shape. So, and when I ask you a question, so what is the rate of change of that function, that quantity? Okay, at a certain value of x. So there, to find out that, that's where your calculus come into picture, differential calculus. Okay, fine. And there's one more thing I have to tell you. Fine. So, okay, so how we are going to do is, so what do we mean, how do you going to understand this calculus is, so therefore, this is the distance. I am not going to call this as a distance anymore. Let us draw it as now I said it can be any function, right? This can be acceleration, distance, many things, energy of a particle, or anything you can, whatever the physical quantity, you can draw the plots and you can do this. Find out its value at a certain particular x value. Okay, so what we are going to do, we are having a graph, we have plotted some function f, okay, and this is, you call it as y, am I right? So you call this as y, this is your y-axis and this is your x-axis, okay, and let me call this function as something like, okay, so a function goes something like this. We never know what it is, okay, and if I ask you what typically the mathematical language is called as a gradient, or you call rate of, if it's a time, you call it as a rate, rate. If it's space, if x is a distance, then you call it as a gradient, okay, but anyway, don't have to bother about it, it's a function. So at certain x, say x1, if you want to find out the slope at a certain x, how do you do is, you take, let me keep it as x only, x1, let us, x0, let me keep. So let me take another one point, x0 plus delta x, okay, and correspondingly here what we have, y0, and here we are going to have y0 plus delta y. Okay, so what am I going to do? So let me connect a straight line. This is not looking like a straight line. Okay, it got a bump in between. Okay, so that I can't help it. The bump is there. Fine. So you connect a straight line, and that's what it gets a slope. Okay, and now if you want to find out what is the slope at y0, that's getting the x0, that's a tangent. What you do is you have this distance is how much? Tell me. Delta x. Am I right? So you start shrinking this delta x here. It becomes smaller and smaller and smaller and smaller and smaller. Some point it becomes very close to x0. Correct? So this point becomes almost it matches. So when this delta x, so this point eventually becomes so close, so at this place your delta x will start approaching 0. And then at the time you don't call it as delta x. When the delta x start approaching 0, you call this delta x as something called as dx. And dx is what you call as, what's the name? Infinitesimal. Infinitesimal is what? It's the opposite to infinite. Okay, so infinite is very large. Infinitesimal is very small. It's almost close to 0. It approaches to 0. Okay, and and this is what. So what happened? So given a function, okay. So given a function, if you want to know the behavior, means I want to know the change of rate of change of the function at certain x. Okay, so what am I going to do? I take an delta x and keep reducing delta x to 0 and find out the function, and that is what we call as your differential calculus. You got it? Basically what? It's simple, trying to identify the slope at every point. Okay, tangent. The slope of the tangent at every point. Okay, so that technique is called as your differential calculus. Okay, so the slope, if you take the y to be any functions, keep trying the tangents at every point. So that's what, so this technique of finding this, what I said, so when it becomes here, so your straight line becomes, the line which you draw, it's going to become a tangent, right? And this tangent, getting this tangent, or the slope of this tangent is what? As I told you, you remember? So when you have, okay, what will be the slope here? Tell me. This will be what? This will be distance is delta y. Am I right? The slope is what? The same way we did, right? This is what will be the slope. Tell me. Tell me the slope of this line. What will be this point? You tell me this point is? x0, y0. And this point is?
x0 plus
delta x plus y0 plus delta y. Okay. So the slope will be what? y0 plus delta y minus y0 divided by x0 plus delta x minus x0. So this is what? Delta y by delta x. Okay, correct. So now you can say, so if you make delta x is equal to 0, you will think this goes to infinity, but it is not. The reason why, when the delta is becoming 0, this also becomes smaller. Okay, so this also reduces. So the ratio, there will be the ratio of two small numbers, small values, two infinitesimals kind of. Okay, so that's why it won't be a 0 infinity. Okay, so this will be a finite number. So it's something like more close to 0 by 0, but it will be a finite. Okay, so you know in your earlier class, you people used to ask, what is 0 by 0? Okay, normally you must have thought 0 by 0 is not 0. Okay, that's undefined. Means you don't know that, you have to find out. So you have to see this is what? Something like infinitesimal. This is not 0 by 0, it's an infinitesimal. Okay, this is when delta y. So now when you make this delta x to 0, approaching 0, delta y will have certain value. this ratio. So when you write that, fine. So when delta y, so when delta x approaches 0, your slope will become dy by dx. Okay, and this is what you call as your differential calculus. Okay, so delta y by delta x when delta x is not 0. When delta x gets closer to 0, almost 0, then this you write it as, represent it as dy by dx, and that is your differential calculus. Okay, so basically what? So that is the slope of this line is dy by dx, correct? So this is the differential calculus. Okay, and now there's something called the derivative. What typically what you call this is a derivative. The meaning is derivative. Okay, so that's what? That's a differential, getting a derivative of this. Now I can always give an antiderivative. What do you mean by antiderivative is, I will give you the slope at some point and I ask you, can you get back the function? You got it? Now what happened? I gave you the function form, this black line. I gave you the function and I asked you at some point what is the slope. Now I am going to give you at some point, I am going to give you the slope. And some behavior, some constant and all will come that you will study in the later on classes of mathematics. So when I give you this derivative, the slope of that line, and if I ask you, can you plot the line? Why? You got it? So I am going to give you dy by dx. Correct? This is what you are confusing? Yeah, I am going to give you dy by dx. That is the slope of this tangent. I am asking you, can you plot your y and x? Okay, otherwise what happened? I am going to give you dy by dx. I am going to ask you, can you tell me what will be the y and x curve? Okay, so that is your antiderivative. You are having from the derivative you are getting that. Okay, and that technique is called as your, this is not an antiderivative, we call it as integration. You must have heard of the word, right? Integration. So what do you call this as? Integration. This is differentiation, derivative. They all are more or less similar quantity names. Okay, we use many names as you grow. As if you end up in doing physics, you will learn all these words. So integration, and this method of from the derivative you get back the function. That is called as your integral calculus. There's something I've missed it for you. I should have told you the beginning itself. Okay, anyway, you can connect it now. What I want to say is something, if you are done in your 10th standard and all, you must have, I think in your 9th standard also you have done the graph problems, right? What you do, so you have, you will be given a function y equal to 3x plus 2 and they ask, represent it graphically. Am I right? So how do? You take a graph and this is a straight line, correct? So what do? You write x and y, right? In the top you write x, the y, and then you make a table like this, box like this. Am I right? And what you do? Basically you need 3 points. You make 3 points you take, right? 0, 1, 2, 3, 4. And then corresponding to 0, you have to find out y. Tell me what will be y for here? 2. Okay, here it is 5.
8, 11, 14.
Okay, what you did, you just substituted the value of x there, correct? And then you do the point, plot. Okay. And you draw the line, straight line, something like that, right? And so if I, instead of y, I will say, see this, if you see here, what you are doing is, you are giving some value. So I can tell, instead of that, I won't give you 0. I tell, why are you starting with 0? Start with -2. -2, -1, 0, 1. You can do still. So it is your choice. Because this number, x, you can choose any numbers. Right? But can y be like that? No, because for 0, y can be only this. If you have 1, this will be only this. If it is 2, this will be 8. This will be 3, this will be 11. It can't be 10. It can't be something 5. For a given value of x, this should be the value. That means the value of y depends upon what? Upon x. So therefore, this is called as your y is called as a dependent variable. Why it is variable? It is not constant, right? It's changing. 2, 5, 8 something. It's a variable. But this variable is not arbitrary. It depends upon your what's the value of x. But do you have any condition on x? You can take x as any value. Right? Doesn't matter. So the x will become your independent variable. Okay, so then what happened? Instead of x and y, what the people write is f in the place of y. I will replace y with something called as f of x, where x is the independent variable. F will be the dependent variable. So this gives me, if I pick y, it doesn't make. Whether y is a dependent or independent, I can't tell. Right? The moment if I write, instead of this equation, if I write f of x is equal to 3x plus 2. The moment I give this form of, instead of y, if I give you this form, I can clearly tell x is an independent variable, whereas your f is a dependent variable. Okay, so that's what this form of. So in the normal, the plot, what you do, instead of writing it as y, we will write it as f. Okay, pardon? Done? Okay, fine. So in the place of y, we will write it as f. Okay, so then what happened? Then we can do the whole thing again. Okay, so how we are going to do? Let me see. Correct. So what they have done is this is what I say. So y equal to f of x. So then we can write down this equation. So I will remove this. Okay. So you understood this portion, right? So now let us come back to the differential calculus. So once I define your dependent and independent variable, the y is actually a dependent variable. Instead of writing y, I can write it as f of x. Let us come back here. So this is what I said, slope, right? So what we have is, fine. What did we write here? Delta y, right? So okay, fine. So this will be what? So then I can write this y0 as f of x0. Correct? That's what you written. Y equal to f of x. When y equal to 0, this is f of x0. And similarly, y plus delta y will be what?
F of x0 plus
Delta x. Correct? Because this is delta x. Correct? This is delta x. Right? So instead of y0 and y0 plus delta y, I can write it in the form of a independent variable. And as an independent variable of x, we can write. Independent variable x. In terms of independent variable x, we can write. So then this slope can be written as, so what we are having, y0 plus delta y0, that is f of x0 plus delta x0, correct? So I am going to write this as, so this one. I am going to write this term as, how am I going to write? So y0 plus delta y0, let me put it in a bracket, minus y0 divided by, this is okay. I will write it as delta x. Okay, have I written this correct? So now what is y0 plus delta y0? Okay, this we found, this is your delta y. Delta y by delta x. Correct. So now tell me, what is y0 plus delta y0? Oops, sorry, delta y. Not y0, na? Delta y. Correct, this is y plus delta y, na? Y, what is y0 plus delta y? That is f of x0. So this will be f of x0 plus delta x minus y0 is f of x0 divided by delta x. Okay, so what we got is from here, so delta y by delta x is equal to f of x0 plus delta x minus f of x0 divided by delta x. Correct? This is what we got here. So now the moment your delta x approaches 0, that's what our differential, right? So when I said when the delta x approaches 0, this will become dy by dx. So then when your delta x approaches 0, this is going to become dy by dx. Okay, but there's a point we're given, right? Okay, let us write it down. Will be equal to this notation. When delta x approaches to 0, what I'll write a notation, you will read in your later on classes. This is called as limit. Limit delta x approaches to 0 and write down this function f of x0 plus delta x minus f of x0 divided by delta x. This is, okay, so what is that? Dy by dx. Dy by dx is a slope, correct? But this is a slope at which point? What is that point? x0. So we represent it with a line and write it as x0. So it says, this is the differential of the function f of x at x0. Okay, you can write as dy by dx or you can write df by dx also. That's also allowed. Okay, so it does not need to write dy by dx. If because you're writing it as f, you can write df by dx also. Whatever the way you want, right? You can write. So then we write. So when we say, so are you able to follow what am I saying? Any doubt you have?
That by delta y by delta x.
Okay.
The delta x both are same, so why can't they get cancelled?
Here. Oh, that's what delta y is what? The difference.
No, the denominators, because if you take the delta x from the RHS to the LHS,
correct, it will cancel, nah? But that's true. Then you are getting only y. This is basically slope.
Okay.
What is this? This is a slope, nah? You have to write down the slope. Why we write the slope? Because slope is the differential. Our whole aim is that, to find out the slope of the tangent. That's what the whole differential is. Different derivative or differential calculus is, right? Of course, if you cancel the negative delta y, you get this portion. That's not, we wanted a slope. You understood? So now, okay, fine. Where did we stop? Yeah, so this is the derivative. So let us write down this derivative in a neat form. So we can write as dy by dx, or we'll write as df by dx at x equal to x0, or you can write like this also or this also, whatever the way, will be equal to limit delta x tends to 0 f of x0 plus delta x minus f of x0 divided by delta x. Correct? Now this is so this is what it says. This is the slope of the tangent drawn at x equal to x0. Okay. On the other hand, if I remove this x0, if I simply write df by dx is equal to limit delta x tends to 0 f of x plus delta x minus f of x divided by delta x. So what is this? I have not defined x0. So this will be what? Tell me. Tangent at where?
At the point.
Any point. X can be anything. This defines a tangent at any point. Okay, so this is exactly the formula for your derivative. Okay, this is what you call as a differentiation. Okay, and this is a differential calculus. Okay, this is a differentiation. So now it says this gives you slope at any x. Am I right? Not at x0. Slope at any x. Now, so this is, so you are given a function f of x. This is f of x. That's what we written, correct? So given a function f of x. Okay, so that way in a straight line you can find out. Okay, so straight line is simple. Slope will be the, because basically tangent, na? It's only a slope is there. Curve itself is a straight line. Okay, so it is just a slope you have tried. So given a function f of x. Okay, and what we have to find out is the slope of the tangent to the function at any point. Okay, draw a straight line touching only at that point. That is called as your differential at that point. Okay, it's not, what I'm saying is a very simple way. Many times it does not always need to touch at one point, but in the neighboring region. It shouldn't touch at the neural point. Maybe if your curve goes something like this and then falls like that. So in that case, this line can go and intersect there. Correct? So don't bother about that. What I'm saying is the neighborhood. In the neighborhood of that point, the line should touch only at one point. Okay? And that line is your tangent. And the differential is the slope of the tangent. That's what we have done it here. Okay? And now you can invert the whole problem. I'm saying, so this is what? This is for any x. I am not defining x0. Any x, this defines the slope at every point of x. Now I am inverting the problem. So I am giving you the df by dx. That is the slope of the tangent at every point. I'm asking, if I give you the df by dx, can you tell me what that function f of x is? You understood? What am I saying? So what we did is, we started with f of x. Okay, we started with f of x. Correct? That's why we plotted f of x versus x and then took the point and then took a point, got a slope and everything. Correct? Now I am not going to give you this. I am going to give you df by dx. df by dx is slope. Slope of the function is the slope of the tangent to the function at any arbitrary x, any x value. I am giving you this value. Now you have to give me what is your f of x. When you put that question, and that's what you call as your integration. How do you get it? Through integration. Getting this f of x from df by dx is what you call as your integral calculus. Okay, so this is what we defined by the differential calculus and the integral calculus. Okay, and I gave you example why it comes in physics, because if you want to find out the velocity at a point, or if I plot velocity versus time, okay, then it gives you acceleration at a point. What is acceleration at a certain instant? There are many things, and later on you will see when you go into integral calculus and all, it can be used to find out the area of certain objects, volume, all those things. What becomes a definite integral that you will learn it in your 12th standard. Okay, so we have discussed, told you sometimes back about that, but these are all that you will study in the 12th standard. So, but this is a basic concept of conceptually how this idea of getting a slope of the tangent. Okay, so that's what you call the rate of change of. The rate of change of the function at a certain point x, or any x. The rate of change of the function at every point of x, any arbitrary x. So that's what is given by your differential equation. And that is a differential calculus. And if I give you the rate of change of the function at any x, and if I say, can you tell me what is the function? That's your integral calculus. They both are inverse of each other. Okay. Now we will see some of the properties of this differentiation. Okay, what they write is the properties of differentiation, correct? Okay, but we will not prove most of the things, okay, because we don't want to, because you will learn all those proof in your 12th standard for currently, because you will be using it in the later on classes also. That's why they given this, and those formulas we can prove it. We'll prove it in 12th standard. But now, what you have to do? You have to mug up, remember it, okay? But if you keep on doing it, you will remember, don't you? If you, as you do more and more problems, that will be very simpler. The first simple, some of the things I'll try to prove, but not everyone. The simple things I will prove, okay? The first property, the properties of differentiation. Okay, the first property is you have a certain function f of x and you have its differentiation df by dx. Now I am multiplying this function with some constant. Say let the constant be s. So I am going to give you a new function that is s into f of x. So let me call it as g of x. Okay. Now, I am asking you, what will be your d of g of dx? Okay. So, in that case, so that is what d of g of x is equal to d of dx of s into f of x. You can write like this also. D by d you can write it like this also. So, this will be equal to s into df by dx. Okay, so just take the constant outside the differentiation. So when you multiply any function with a constant, the differential also will be just multiplied with the constant. That's what it says. Okay, so you can prove it also. This proof of this is very simple. How do you prove? You remember what we had? Let us write it out. df by dx. What's the formula? Limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x, right? So now I want to do it d of, this is a function of multiplication, right? sf by dx, correct? So what this will become? Limit delta x tends to 0. This will become s into f of x plus delta x minus s into f of x by delta x. S is a constant. So you can take outside both of this, right? So then what it will become? I will take this s from here and write it as some s into this, correct? And now, when delta x goes to 0, will s change? Because s is a constant, some number, that doesn't matter at all. Whether delta x goes to 0 or whatever, wherever the hell it goes, but s is going to be as it is. So, I can write it outside. Am I right? So, s into limit of delta x tends to 0, f of x plus delta x minus f of x by delta x. Now what is this?
Okay, that is delta
df by dx. So this is what? S into df by dx. That's what we wrote here. Okay, so the differential, so if you multiply any function with a constant, the corresponding differentiation also just multiply that constant with the differentiation. That's the first property. Okay, so let us, the second property is what is called as additive property. Okay, when you have two functions. This also you can prove it. Okay, I'm not going to prove these things. Okay, anyway, that you will start proving in your 12th standard. Okay, and okay, suppose you have two functions. What am I going to do is, I am going to give you two functions, that is f1 of x and f2 of x. This will have a differentiation df1 by dx. This will have a differentiation df2 by dx. Okay. Now, they both are individual functions, correct? Now, I am asking you, so what will be differential of f1 of x plus f2 of x? Okay, so what it means, I am asking what is d by dx of f1 of x plus f2 of x. So if I give you this individual function, this one, okay, so say something like this. For example, I am going to give a function, this will be f1 of x is equal to, say, something like 3x cubed plus 2x square, and f2 of x is equal to, say, some 5x power 4 plus 3. Okay, so they both have an individual differential we can find out. You will see how we are going to do all those things. We have a lot of formulas are there. So we have found out a differential. Now if I keep add them both, f1 plus f2, that is this. When I add them both, I am asking what will be the differential of that addition. Okay, that means what, when you addition, what happens? This is going to, when you add up the one, f1 plus f2 will be what? 5x power 4 plus 3x cubed plus 2x square plus 3. I have added this. Okay, individually this is having one differential, this is having one differential. What will be the differential of this? The differential of this will be just again the sum of these two differentials. Okay, that is what? This will be df1 of x by dx plus d, we don't write that, f of x, that's no need, df2 by dx. You got it? So this is the second property. So the first property also we wrote, second property is when sum of two. Third property is a multiplicative. If you have the same thing, this I won't take the example because this is going to become complicated. So we don't prove it from the examples like that. Suppose you have these functions like this. You are given two functions, f1 of x and f2 of x. And their corresponding differential is f df1 by dx, df2 by dx. Okay. I am asking what is the differentiation of d by dx of f1 into f2. Earlier I multiplied, now I am going, earlier I added, now multiplying. This case, what this will be, f1 into df2 by dx plus f2 into df1 by dx. Okay, this is the formula, you have to remember it. You can prove it all later on, we can prove. And this is one of the important things is these formulas, if you remember, many of other formulas, you can actually get it from here itself. What will be the division of these two functions? We saw addition, we saw multiplication, we saw. Now, what will be the division of these two functions? That is what? D by dx of f1 by f2. Individually, they are the derivative, differentiations of these functions. So, how this will happen? Okay. This formula is also important. Okay, we can prove it, but for time being, accept this formula. Accept means mug it up. Yes, correct. So what it becomes? So this is going to become 1 by f2 into df1 by dx minus f1 by f2 whole square into df2 by dx. So this you can prove it also. Later on we will prove it. Okay, in the later on classes you will prove. For time being you have to accept all these formulas. Okay.